Assalamu alaikum everyone, welcome to your favorite physics channel, College Physics. Here you will find work solutions to past papers by experienced teachers and A-star students. So please subscribe to our channel and forward it to other Cambridge learners. Thank you.
Okay, P2 variant 23, May-June 2021. P2 is our multiple choice question, so let's start. Question number 1. The diagram shows a plastic rod alongside a ruler. What is the length of the rod? Okay, let's zoom in. So this is, okay, let's see. We have from 0 to 10, and in between 0 and 10 we have 4 markings. Okay, 1, 2, 3, 4. Therefore, if you divide, and we have how many spaces? 1, 2, 3, 4, 5 different spaces. Now if you divide 10 by 5, the answer is 2. Therefore each dial or each line is 2. So here this is 2, 4, 6, 8, 10. It all lines up. So from 2 to, what's between 8 and 10? 9. Now we have 9 minus 2 is equals to 7. Therefore it's the length of the plastic rod is 7. You can also do 2, 4, 6 plus 1. All of these plus 1 is 7. So 7 centimeters, however you want to do it. So C, 7 centimeters. 2. 4 balls of different masses are dropped from heights shown. Air resistance may be ignored. This is an important sentence. Which ball has the smallest average speed? Now, when we're talking about an instance when there is air resistance, okay, air resistance exists. The lighter mass, take it, lesser mass, so the lighter one has higher air resistance. For example, if we're talking about a ball and a feather, take it, they're in a normal environment, just hamara atmosphere, normal atmosphere, and there is air resistance because we live in normal atmosphere, there is air resistance. The feather will take a longer period of time to fall to the ground than the ball because it has a lighter mass. So it will have air resistance. But this is very important to note this. If you do not know this and you do not believe what I'm going to say next, go to YouTube, watch a video. When there is 0 air resistance, therefore when there's a vacuum. Now obviously this is not possible on Earth naturally, so you have to create a vacuum environment when there's no air resistance or there is vacuum. When you have a ball and a feather, since there's no air resistance, it doesn't matter which is mass is what. Although we know that the feather's mass is lesser than the mass of the ball, they both reach the ground at the same time. When dropped from the same height, they reach the ground in the same time. How does that make sense? It makes sense because there's no air resistance. Air resistance affects those with a lesser mass. If there's no air resistance, it doesn't affect it. They both fall with what? The same time if they're left from the same height. Why? Because they both still have the same G. Now I said remove air resistance, not remove gravity. If there was no gravity, it wouldn't fall. And that's not possible on Earth, right? Same G. G is what? The acceleration with which they fall down, which is 9.81 meters per second squared. So they both accelerate with this. They have this acceleration, therefore they have the same speed, and then they reach the ground with the same time. Now over here we have no air resistance, therefore it doesn't matter, although we've been given the masses here, but it doesn't matter which one has which mass. It makes no difference because there's no air resistance. Now we know that they all have the same G or same acceleration, which is 9.81 meters per second squared. Therefore the speed increases by, this is acceleration, therefore the speed increases by 9.81 meters per second every second, right? Therefore the one that is traveling with a higher length or travels more distance, therefore has more time traveling, will have higher speed. The one that has the maximum amount of length covered, therefore it's falling for a longer time, will have the most speed, right? So when D falls to the ground, its speed will be higher than the speed of C. When it touches the ground, will be higher than the speed of B, will be higher than the speed of A. Sorry, not B. Speed. Understand? Because if they travel a longer distance, it will accelerate more, because acceleration, obviously, it's going to accelerate along with the distance it traveled. So the answer with which ball has the smallest average speed will be A. Because let's just say they all start from the speed 0, right? 0. Now over here is traveling 4 meters. In 1 second, let's just say it reaches here. So its speed will be 9.81 meters per second. And now the second it reaches here, it will be around 19 meters per second, for example. This 1 second over here, this will be 9.81 meters per second. यहाँ पर we'll have something around, like, let's just say 14 meters per second. Here we'll have 9.81 here, and here will be less than 9.81, if you understand what I'm trying to say. So the answer will be A. Number 3, a cyclist rides 300 meters up a slope in 50 seconds, then rides down the slope in 25 seconds. What is her average speed for the whole? Take it. So speed is equals to distance upon time. Now if we're talking about average speed, we'll talk about total distance upon total time. Now total distance is she rides 300 meters up a slope, and then she rides it down a slope. So it's 300 plus 300, which is 600. Upon she rides it up at 50 and rides it down at 25, so 75. 600 upon 75 is 8. So B, 8 meters per second. 4. An object is on the surface of the earth. Which statement describes the weight of the object? Now, if it's on the surface of the earth, its weight is obviously proportional to its mass, and the G is 9.81. But we're talking about which statement describes the weight. Weight is the amount of gravitational force applied by the earth on the object, and that is C. 5. The tank shown has dimensions 5 meters by 4 meters by 4 meters. It is completely filled with water with a density of 1000 kg per meter cubed. अब हमसे पूछा गया है कि what is the mass of the water? Now, we all know the formula. Density is equals to mass upon volume. So if we're looking for mass, what will our formula be? This mass is equals to density volume. So density, we have 1000 multiplied by mass, multiplied by volume. Volume will be 5 by 4 by 4. So 5 by 4 is 20, 20 by 4 is 80. So 80 multiplied by 1000, you can just see that it is going to be D. You don't even need a calculator. 6. The extension load graph for a spring is shown. The unstretched length of the spring, unstretched, is 17 centimeters. And when an object is suspended from the spring, the length of the spring is 19.8 when an object is suspended. Therefore, it's talking about its extension. When an object is attached to the string, it extends, and its length now turns from 17 into 19.2. So the extension in length when it moves from 17 centimeters to 19.2 is equals to 2.2 centimeters. That is the extension. So 2.2 is over here. What is the weight of that object? So we have load, and then we have extension. You can see load and extension. So what we're going to do is we're going to draw a line at 2.2, and it lands at 3 newtons. So the answer for number 6 is D, which is 3 newtons. Number 7. A car of mass 1200 or 1200 kgs is traveling along a horizontal road. This is the direction of motion is to the right. The driving force of the engine is 4,000 newtons and the frictional force is 1,000 newtons. So let's talk about its resultant force. If its force towards the right is 4,000 and then towards the left is 1,000, the resultant force is obviously going to be towards the right, and it will be 3,000 newtons because 4,000 minus 1,000 is 3,000. Now its mass is 1,200 and its force is 3,000 newtons. What is the acceleration of the car? F is equals to ma. F is equals to ma. So acceleration will be force upon mass is equals to 3,000 upon 1,200. And the answer for that is 2.5, which is C, 8. Okay, object X moves to the right along a frictionless, it is frictionless, therefore there's no loss of energy, towards a stationary object Y as shown. They make a noise as they collide, and then both object move to the right. Which equation is correct? A. Change in momentum of X is equal to change in momentum of Y. B. Impulse of force acting on X is equals to impulse of force acting on Y. Impulse is change of momentum. C. Kinetic energy of X before collision is equals to kinetic energy of X plus kinetic energy of Y after collision. That makes no sense. Momentum of X before collision is equals to momentum of X plus momentum of Y after collision. That makes sense. Okay, let's talk about what's happening. We're having a collision with a frictionless surface. Frictionless surface, therefore, the kinetic energy and the momentum are conserved. It's an elastic collision. So elastic collision, what happens, or even if it's an inelastic equation, momentum before collision is equals to momentum after collision. Before versus after collision. Now before collision, it's mu plus 0 because this one has no speed is equals to mv plus m2v2. Say m1v1 or m1u1 is equals to. Now this is described by D. Momentum of X before collision is equals to momentum of X plus momentum of Y after collision. You all know this formula. m1u1 is equals plus m2u2 is equals to m1v1 plus m2v2. It's basically this formula. 9. A stream flows out of a lake and down of a hill, which best describes change in energy store. Okay. Stream changes in energy. So when we have a stream, initially what energy do we have? It's moving. First, remember that it's moving down a hill. When it moves down a hill, potential energy is being lost. Okay, so in B and C, we can see the potential energy is included. Now potential energy is converted into kinetic energy, and that is described by B. When something falls from a height, obviously the interconversion is between potential energy and kinetic energy. When something moves up, kinetic energy decreases and potential gravitational energy increases. When something moves down, gravitational potential energy decreases and kinetic energy increases. Now kinetic and internal doesn't make a difference. They're both energy which is being created from gravitational potential energy. Converted. Energy cannot be created. 10. The energy input to a device is E. Energy input. The amount of energy wasted by the device is W. Which expression gives the efficiency of the device? Now, input is E upon output input is E. This is input and multiplied by 100. Over here we have the output. Now output is what? Input minus the energy that is wasted. So input minus energy that is wasted gives us the output. So this over here, number 10 is C. 11. A builder lifts 30 bricks from the ground into a platform 2 meters high. Each brick has a mass of 4 kgs. Therefore, the total mass will be 3, 6, 9, 12. 120 kgs, because we have 30 bricks and each is 4 kgs. 30 times 4 is 120 kgs. What is the work done against gravity by the builder in lifting the bricks into the platform? So work, what is the formula of work? Work is equals to force into distance. Now force, we can see it's 120 kgs. If you convert that into weight, it is 1,200 newtons. Multiplied by distance is equals to 2 meter high. Meters is its SI unit. So 1,200 multiplied by 2 is 2,400, which is D. 12. A book has a mass of 400 grams. 400 grams, if you convert that into kgs, because we need to use our SI units, is 0.4 kgs. Do not forget to convert into your SI units. The surface of the book is in contact with the table, which has the dimensions 1 meter by 2 meter. Therefore, the area is equals to 0.1 multiplied by 0.2 gives us 0.02. Area is equal to 0.02 meters squared. The gravitational field strength is G. What is the pressure exerted on the table due to the book? Pressure is equals to force upon area. Now force, we have 0.4 kg. We multiply that by 10. We get the weight, which is a force. 0.4 multiplied by 10 upon area is 0.02 meters squared. So when you calculate this, the answer is 200 newtons per meter squared, which is D. Question 13. The diagram shows a full tank of water. The mass of water in the tank is m, the density is rho, the height is h. Which equation gives the pressure due to the water at the bottom of the tank? Now, when we're talking about a liquid or the sea, anything, when we're talking about the pressure below the surface, the formula is P is equals to rho G H. P is the density, G is G, which is gravitational field strength, and H is the height. So over here, A matches with rho GH. 14. A liquid at room temperature is put on a metal surface that is also at room temperature. A student blows gently across the liquid and its temperature decreases. What causes the liquid to become cooler? So let's see our options. A. Bubbles of water vapor from the liquid go into the air. No, because it's at room temperature. B. The moving air reduces the kinetic energy of all the particles in the liquid. That's very far-fetched. C. Thermal energy flows through from the liquid into the metal. D. The more energetic particles in the liquid escape into the air. That actually makes sense, because if we have liquid, whether it's placed on top of a metal, whether it's placed on top of wood, whether it's placed on top of whatever what, it is volatile. It's a volatile liquid, so there will be evaporation of some sorts, and when you blow on it, it will cause it to evaporate even more, and the more energetic particles escape in the air, and they take energy with them. So the remaining liquid's energy decreases and its temperature decreases and it becomes cooler. So the answer for 14 is D. 15. Very small pollen grains are suspended in the water. A bright light shines from the side. When looked through the microscope, small specks of light are seen moving in a random jerky manner. So what do we have here? We have an eye. It's viewing pollen grains in water via a microscope, and then we have bright light coming in from the right hand side. Now let's see the motions are described. Small specks of light are seen to be moving in a random jerky manner. Therefore, let's just say this is a speck of light, so it moves like this. It doesn't say that it's colliding. It doesn't say that the specks of lights are colliding with each other and with the wall. They're just moving in a random jerky manner. So now what is the explanation for this? What are the moving specks of light? Obviously, it's the pollen grains. It cannot be water molecules because you can't see water molecules. Even with an electron microscope, you can't actually see molecules and atoms. Now, A, pollen grains are being hit by other pollen grains? No. Otherwise, we'll say, what would have been the option? It would have said that uh, spots, specks of lights are colliding with each other and with the wall. No, they're not being hit by other pollen grains. Pollen grains are being hit by water molecules. That's correct because we can't see water molecules. Now, if this is moving from here to here and suddenly it moves here, why did it move from here to here? Because obviously another water molecule hit it. So it moved from here to this place or wherever. And you can't see water molecules. Therefore, it appears to be moving in a jerky manner when it is just being hit by water molecules. This is Brownian motion, the motion of gases when they're hit by each other and with the walls and they move in jerky manner. But since you can't see them, this is the same way you can't see water molecules here. Number 16. The liquid level in the thermometer rises when the thermometer is placed in hot water. What causes this? Obviously, the liquid, when there's heat, it gains energy and the attraction between the particles decreases and it expands. 17. A student calculates the energy needed to rise the temperature of an aluminum block from 50 degrees to 60 degrees. He then does an experiment to measure the energy used to do this. Which statement about the measured energy is correct? A. Okay, so the increase in temperature is 10 degrees. Let me just say increase in temperature is 10 degrees Celsius. Then he does an experiment to measure the energy used to do this. Which statement about the measured energy will be correct? A. The measured energy will be greater than the calculated energy because some energy is transferred to the surroundings. Is that correct? Yes, it's correct. Now let's see what we're actually saying. That they gave a specific amount of energy which converted 50 degrees to 60 degrees. Now it is very obvious. For example, let's just say 50 joules were given to convert the temperature, which is not true, obviously. Let's just say 500 joules were given to convert the temperature of an aluminum block from 50 degrees to 60 degrees. Okay, 500 joules were given. Now, if you say that the aluminum block took all of those 500 joules, you're wrong. Why? Because obviously it is without a doubt some energy is lost to the surrounding. However, let's just say that the source of energy and the aluminum blocks are really, really close. Yet the aluminum block it has a temperature higher than the surrounding, so energy will move out. So the answer for number 17 is A. 18. Which row correctly describes a liquid that is boiling? Now, evaporation and difference, there's a difference between evaporation and boiling. Evaporation takes place at all temperatures. Boiling takes place only at a specific temperature. For boiling, it takes place throughout the surface, and for evaporation, it takes place at the surface only. And because it's boiling and it's taking place throughout the surface, therefore, obviously, we will see bubbles because it's taking place throughout the liquid. Let's just say if it's only taking place at the top of the liquid, bubbles won't form. But at the bottom of the liquid is being converted to gas. So that gas comes up to the surface in the form of a bubble. So 18 is D. 19. 3 students are planning an experiment to test thermal conduction in different materials. The student each propose a hypothesis. 1. I think that the copper rod will be a good thermal conductor because it is a metal. Is that correct? Yes, that's correct. Metal conduct heat. B. I think the glass rod will be a good thermal conductor because it has free electrons. Wrong. Glass does not have free electrons. That is metal. 3. I think the wooden rod will be a poor thermal conductor because it can only transfer energy along the rod by vibrating of the lattice particles. That's correct. It doesn't have free electrons, but because it's a solid, it has lattice particles
or molecules, whatever, set out in a lattice pattern, and they will vibrate and transfer the energy, but obviously it will take a very, very long time. And most of the time, the energy won't even reach from one end to the other because it will be lost to the surroundings. So the answer for this is B, because only 1 and 3 are correct. 20. A copper plate is shiny on one side and is painted dull black on the other side. The plate is heated to a high temperature. A person places his hands at equal distance from either side of the plate, close to the plate but not touching it. So we have a very hot copper plate. We have one side that's shiny and one side that is black. Why does the hand near the dull black surface feel much hotter than the near the shiny surface? Obviously, because dull and black, it emits and absorbs heat or radiation better. So the answer for this is A. The dull black surface is a better emitter and an absorber of radiation than the shiny surface. 21. A water wave passes into a region where the wave moves more slowly. As it passes into the slow region, what happens to the frequency and what happens to the wavelength of the wave? Now the formula we have, V is equals to F lambda. Now, frequency only changes when the source of the wave, there's a movement, simple harmonic motion or whatever motion, anything vibrating produces a sound or a wave. Now, the frequency of the wave only changes when the source or the vibration changes. So, therefore, we can say that the frequency will remain constant because it doesn't talk about anything of the source of the frequency or the source of the wave moving. Now, it moves into a region where the speed reduces. Now, V and lambda, or speed and speed and wavelength are both, they're both what? They're directly proportional. So if speed decreases, lambda will also decrease. They're both going to decrease, and frequency stays constant. So frequency remains the same and wavelength decreases. So the answer is C. 22. Light traveling at a speed of 3 into 10 to the power 8 meters per second strikes the surface of a glass block and undergoes refraction as it enters the block. The diagram shows a ray of light before and after it enters the block. What is the speed of light in the glass? Now, for the refractive index, we have two different formulas. First, sine I upon sine R. Second, C upon V. Now we have this, we need to find this. So we equate both of these equations. We get sine incident ray, which is 55, upon sine refractive ray, which is 33, is equals to C, which is 3 into 10 to the power 8 meters per second upon V. When you do this, the answer for V will be 2 into 10 to around 1.9 something, so it will be around 1.98. So 2 into 10 to the power 10 meters per second. 23. A beam of light is monochromatic. Chro meaning color, mono meaning same. Now when we have light, which is of the same color, it has the same energy, it has the same wavelength, it has the same frequency. So when we're talking about 23, what does monochromatic means? That all the waves must have the same frequency only. Yes, that's correct. Because frequency is related to energy, is related to lambda. So speed and lambda are not the same and they're different. However, frequency depicts its wavelength and depicts its energy. So the answer for 23 is A. An object is placed in front of a thin converging lens. The diagram shows the path of two rays from the top of the object. An image is produced or formed on a screen to the right of the lens. How does this image compare with the object? So first, let's do this. We'll take our rays and we'll form an image with our rays. So we're going to do this. I'm going to do the other one. And we're going to form an image here. Now, obviously, as you can see, this arrow is larger than this arrow. So the object is definitely what? It is larger. The image is larger than the object, and you can see it's inverted. It's pointing downwards rather than pointing upwards. So inverted. Therefore, the answer is A. 25. Which row correctly describes what happens to the frequency and the speed of the electromagnetic waves as we move through the spectrum from gamma rays to radio waves? Now, I'm just going to draw the electromagnetic spectrum, and I feel like I did not describe this question correctly as well. I've been feeling this way, so let me just describe both of them at the same time. So let's just start from gamma rays. Then we have X-rays, we have light. Then we have microwaves, radio waves. Take it. This is our entire electromagnetic spectrum. Now, these are all electromagnetic waves. They all have the same speed. They all have the same speed, which is 3 into 10 to the power 8 meters per second. They all have the same speed, whether it's in air, whether it's in vacuum, it doesn't matter. Now, what changes is the frequency and frequency and energy alongside with the wavelength. Now, gamma rays, they have the maximum amount of energy, and when energy is high, frequency is high, because we have a formula E is equals to FH. Take it, this is Planck's constant. E is equals to HF. So when energy is high, frequency is high. So gamma rays have the maximum amount of energy and maximum frequency. Now, when we talk about light, we have different colors, right? We start off from violet on one end, and we have red on the other end. Now, violet has the most energy. Violet has the most energy because it is closest to gamma rays. On the left-hand side, the energy is higher. So let's just talk about, we spoke about a monochromatic light here, right? Let's talk about violet. Now, violet will have this, all the molecules of violet will have the same energy and the same frequency, because it depends, the frequency depends on the energy. And the radio waves, they have the maximum amount of wavelength, but the minimum amount of energy and frequency, and the same way for gamma rays, they have the minimum amount of wavelength. It's indirectly proportional because V is equals to F lambda. Now, they all have the same speed. Speed is constant. Therefore, frequency and lambda are indirectly proportional. You can see that here, where the frequency is highest, the lambda is lowest. Where the lambda is highest, the frequency is lowest. That is proven by this relationship. So when we have monochromatic lights, they all have the same frequency. Therefore, they will have the same energy and they will have the same wavelength. Therefore, I chose A over here. Because if it talks about all the waves in the beam must have the same speed, that's true, but every color has the same speed. Every single electromagnetic wave has the same speed. And amplitude is, we don't even talk about amplitude, it doesn't really matter, because amplitude doesn't affect energy or frequency or speed or wavelength. None of these things are affected by the amplitude. Now, question number 26. The diagram shows a model of a sound wave passing through air in an open tube. What is the region Q? What is the region Q? You can see that the molecules are spaced around. There's a low pressure. There's less molecules, so low pressure. Sorry, not here. Low pressure. And what happens when we have low pressure? We have a refraction. A compression is where there's high pressure. So answer is D. Number 27. The sound from a loudspeaker must pass through two materials to reach a microphone. Which combination of materials gives the shortest time for the sound to reach the microphone? Now, sound waves are medium waves. Therefore, the denser the medium means more the speed of sound, because it has more molecules for it to vibrate and pass the sound through. So which combination of materials give the shortest time? Shortest time means maximum speed, means maximum density. Now, as you can see, in the material 1, copper is the most densest, and material 2, aluminum is the most densest. So answer for 27 is C. 28. A bar magnet picks up two steel bolts. Which diagram shows the magnetic poles induced in the bolt? So let's see A. We have north and south. Now, how is south attracted to south? This is repulsion, so it's definitely not A. Let's move to B. Again, we have south and south. Repulsion, not possible. C. North and south. South and north, yes, attraction. Now, south and south, there's no attraction between south and south, so this is also not the answer. The answer must be D. Yet, we'll check it again. North, south. South and north, yes, there's attraction. South and north, yes, there's attraction. So the answer will be D. 29. A student rubs a plastic rod with a cloth. The rod becomes positively charged. Whenever we talk about anything being positively charged or negatively charged, you should always know that positive charges do not move. When something is being positively charged, electrons move out of it. When something is being negatively charged, electrons move into it. So when something is positively charged, it has lost electrons. C. Nothing can be done with protons. Protons can't be gained or lost. And if it gained electrons, it will become negatively charged. 30. An isolated metal sphere is positively charged. It is then brought near to another isolated metal sphere that is neutral. What happens to the charges in the neutral sphere as a positively charged sphere is brought close to it? Now, let's talk about the positive charges throughout this because they won't move. The positive charges remain the same, they can't move. However, since we have a positively charged metal sphere brought near this here, so the electrons will come towards it. The electrons move towards the left-hand side. As you can see, the same amount of positive particles are on the left side and the right side. However, because the electrons all move to the left side, this right side now is positively charged and the left side is negatively charged. So what happens for 30? The answer is D, because the positive charges do not move. Every other one says that the positive charges move. Not true. Positive charges move. No. Positive charges do not move, but some negative charges move to the left. So the answer is D. Question 31. The diagram shows a circuit containing a cell, 2 resistors, a switch, and a voltmeter. When the switch is open, the voltmeter reads 1.5 volts. When the switch is closed, the voltmeter reads 2 volts. What is the EMF of the cell? Now, let's talk about, I think the proper voltage of the EMF is obviously denoted when the switch is closed, because then both the resistors are taking the voltage and we can figure out what the total voltage or the EMF of the cell is. Now, when 2 resistors are in series, if you add the voltage, that becomes to the total voltage of the cell. So when the switch is closed, BC volts is equal, A volts is equals to B volts plus C volts. So when the switch is closed, because both the resistors are in series. So we're told when the switch is closed, the voltmeter reads 2 volts. So this would then be 2, regardless of what this and this may be. Therefore, the EMF of the cell, or the total volt of both the resistors is 2 volts. So that is also the EMF of the cell, which is C, 2 volts. 32. A 4 ohm resistor and a 12 ohm resistor are connected in parallel. What is the effective resistance of both of these resistors together? So now when 2 resistors are in parallel, the resistance is 1 upon R total is equals to 1 upon R1 plus 1 upon R2. So we have 1 upon 4 plus 1 upon 12. Now, to add both of these things, you need to, if you don't have a calculator, you can say is equals to 3 upon 12, because you need to have the same denominators to add, plus 1 upon 12, which is 4 upon 12. So you can either do this or you can just use a calculator, I guess. And then the answer for 32 will be, you can put 12 upon 4, which is equals to 3 to get resistance. So B. 32. Which combination of 2 gates will result in the truth table shown? Now, to make this easier for you guys, I added the truth tables of each logic gate. Now, first we have 2 zeros inputs, which is giving us the output of 2 0 inputs, which is giving us an output of 0. So let's see which truth table first actually does that. So AND gate does that, and OR gate does that. Therefore, the first, it has to be AND gate or OR gate. Let's write down our two options. The first one will either be AND, OR. Second, we have 0, 1, which gives us a 1. So now out of the AND gate and the OR gate, we have 0 and 1, which gives us 1. 0 and 1, which gives us 1. It has to be a OR gate. Okay, both of these line up with OR gate. This one will either be AND or OR. This one will be OR. This one will also be OR. Also, it can be 0 and 1 gives us a 1. It can also be an AND gate. So, or an AND. Or an AND. Now, 1, 1, which will give us a 1. This can be either an AND or an OR gate. Now, what will result in the truth table shown? It has to be either one of these things. So first, let's talk about the AND gate. If we have P and Q, which is 0 and 0 into an AND gate, 0 and 0 will give us an output of 1. So the input will be 1. Now 1 with a NOT gate gives us output of 0. So yes, okay, the first one lines up with this. The first one lines up with A. The first one lines up with A. Okay, let me just get rid of this. This was just for explaining, okay? The first one lines up with A. Now let's see the second one. 1 and 0 gives us 1. So if we had 1 and 0 at P and Q, we would 1 and 0 would give us a 1. Now 1 output would give us a 0. So it's not correct. So it is definitely not A. Now we're going to check with B. So 0, 0 gives us the output of 0. P and Q, if P and Q of AND gate was 0, 0, you would get 0 here and the output would be 1. So obviously it's not B because it doesn't match with it. Let's see with C. 0, 0 as the input of NOR gate would give us a 0 here. Then it would give us a 1 here. And 1 into a NOT gate gives us the output of 0. So yes, it matches with the first one. Well, actually, it matches with the first one. True. Okay, if we had 0 and 1, at P and Q, for NOR gate, 0 and 1 would give us a 0. And 0 output will give us a 1. So it works with this as well. 1, 0, it would make the same thing. It would give us this as well. Now 1, 1. If we had PQ 1, 1 over here, it gives us a 0. And 0 output with a NOT gate gives us a 1. So it lines up. The answer is C. 34. A solenoid is connected to a very sensitive ammeter. A rod is inserted into one end of the solenoid. The ammeter shows that there's a small electric current in the solenoid while the rod is moving. Now, what does this mean? That when we're putting a rod inside and outside of a solenoid, or when we're moving it around the solenoid, there's an electric current in the solenoid. That is only possible if it is a magnetized steel rod, because this is electromagnetic induction. You know that when the magnetic field around a solenoid or around an electric conductor is changing, it produces an EMF, which induces a current to oppose the change that is causing the EMF. So it has to be a magnet rod. It doesn't make a sense if it was a heater copper rod, a nylon rod, or uranium rod. Whichever one of these rods, moving them in and out or around the solenoid would not produce an electric current. 35. A 12 volt 36 watts lamp shines at a normal brightness when connected to a mains transformer, assuming the transformer is 100% efficient. Which row shows the number of turns in the secondary coil and the current in the main wires? So let's first talk about, okay, we're given the power is equals to 36 volts. Now you know that power remains constant regardless of the primary or secondary coil P1 is equals to, or power primary is equals to power secondary, because the efficiency is 100%. Now, let's talk about the voltage. P is equals to IV. P is equals to IV. Now, first we need to find I, then we'll multiply by V to find the power in the current. So let's find the, first we're going to find the number of turns and we can find current. So you know that number of turns in primary upon number of turns in secondary is equals to voltage of primary upon voltage of secondary. So primary number of turns we have is 1000, upon secondary we don't know, and voltage in primary is 240 and voltage in secondary is 12. So basically multiply 12 by 1000 divided by 240 and we're getting 60 turns. So it can be either A or B. Now let's talk about the current in the wire. Now we're talking about the current in the main wire. Take it in the mains wire. So we're not talking about the current here, we're talking about the current here. So we know that the power in both of them is 36 watts is equals to whatever current multiplied by the voltage. P is equals to IV. Voltage over here is 240. So I is equals to 36 divided by 240. The answer is 0.15. Therefore, we'll get A. 36. Diagram 1 shows a wire carrying a electric current into the page. The wire is between the poles of a magnet. So we have a magnetic field going from north to south. This is our magnetic field. Diagram 2, north to south, we have a magnetic field going on here. The focus is produced on the wire acting downwards, acting down towards, a force is produced on the wire acting down towards the bottom of the page. So we're given the direction of force already. We're given the direction of force. What are we going to use for this? Our left hand. Diagram 2 shows the situation after the current is reversed. Now let's take our left hand. Okay, you know that the thumb is the direction of the force, the middle finger is the direction of the current, and the index finger is the direction of the magnetic field. Now if I were to draw your hand, and we're looking at diagram 1, let's just say I'm drawing your hand, which I won't be very good at, but anyways, this is your index finger, the finger you point with. This is your thumb, is pointing downwards, thumb, okay, and this will be your middle finger, index, thumb. Okay, thumb shows force, index finger shows what? Magnetic field, and this shows electric field or electric current, the direction of M. Basically middle finger shows the direction of movement of positive charges, the direction of current. For example, if we were told that electrons are moving in this manner, the direction of current would be this. So this would be direction of middle finger. Take it, middle finger. So let's do this for diagram 2. Now the direction of the middle finger or the direction of current is outwards, and the direction of your middle finger will be upward, pointing upwards. This is your nail, is pointing upwards. Your index finger is towards the north. Your index finger, this is middle, and your thumb is pointing where? Your thumb is pointing here. This is your thumb, right? So where is it pointing towards? It's pointing towards the left hand side of the face, which indicates what? Direction of force. 37. The charge on a proton is E. So the charge on an electron is minus E because it is negative, and charge on a neutron is 0. It has no charge. So 37 is D. 38. The diagram shows alpha particles incident on a thin metal foil. How does the motion of these particles give us the evidence for a nuclear atom? Now, if you know that if we did not have, let's just say, a nuclear atom or positive nucleus of a cell here, it would move straight, but it did not. It repulsed due to the positive nucleus of a cell and it moved in a different direction. So the answer for 38, let's see. A, most particles passing through with minimal deflection shows that the atom is mostly empty space. Yes, that is correct. Because if it wasn't, let's just say okay, you know that this experiment, first of all, it tells us about the positive nucleus center. Second, it tells us that most of the space around an atom is just space, because there's so much of space between the orbits of electrons. So 90% of the space or 95% of the space of an atom is empty space. And we're told that because the deflections are not that much. If, let's just say, we had all of these closely positive nucleuses of cells, then the deflections would be crazy, wouldn't they? They'd all just deflect backwards, but they don't. Many of them pass through, many of them deflect very less. That shows that there are many spaces through which the positive charges can just move without being deflected or without going through repulsion. If there's not much repulsion and not much deflection, it means that those places are non-nuclei of the atom. So those places are what? Spaces. So that is cleared by A. If you're still confused, we can still go to the other options. B. Most particles passing through with minimal deflection show that the mass of atom is uniformly distributed. It's not. If it was uniformly distributed, then the nucleus would be so large, it would be equivalent, then all the masses would be distracted, and what would it do? It would push all the alpha particles coming backwards. C. Large deflections of some particles show that the atom is mostly empty space. No. If we had large deflections, it would be because the atom is mostly made up of the positive nucleus. If we had large deflections, but we don't, because it is not because it is empty space. This part is correct. Then we would have small deflections. Large deflections of some particles show that the charge in the atom is uniformly distributed. Incorrect again. Now, if you do not understand this is a very theoretical concept. You need to go study it in your textbook to understand it. 39. Radium-226 is an alpha emitter. When it emits alpha particles, which is A24. It is implanted inside cancerous tumors. It is safe to use to kill the cancerous cells, but not the healthy ones surrounding the tumor. Which properties of alpha particles compared to the emission of other emissions enable this use of radium-226? Ionization of alpha particles we know it's high, and the penetration is low. Therefore, it doesn't affect the other healthy ones surrounding the tumor. So the answer for 39 is B. 40. The graph shows the activity of radioactive source over a period of time. What is the half-life of the source? So we're going to use this graph to find the half-life. So first, let's jump from 120 to 60. Let's see, where does it take us? It takes us here. The time taken from it to move from 120 to 60 is 2 minutes. Now let's go from 60 to 30. 60 is what? 60 is at 2 minutes and 30 is at 4 minutes. So over here also it takes us 2 minutes. So the half-life is B, 2 minutes. I hope you all understood everything. If you did not, please mention in the comments and I will try my best to get back to you. And I will see you guys for the next video.